So hi there folks, we're now in our next video in the introduction to statistics. Okay, and in this video we're going to have or present our organization and presentation of data. Specifically, we're going to present the frequency distribution and some graphs of quantitative data. Since we lack those videos, we are already done with our qualitative data, so make sure to check them out. What I did here is I divided the screen into three parts. The first part on the upper right here is the presentation itself. A big part of the left is the Excel file wherein we can see some sample data here in which we're going to use later in our video. And here down below is a sketchpad. We will just use this if ever there will be some formulas in the slide. So I ought to type it here. Okay, I will ought to type it here. Okay, instead of going back to the slides before. That will be quite tedious to do. So whatever formula that will come out of this presentation, I will sure to write it here. Okay, so let's proceed with this organization presentation of data. Before we will be having into more deeper details first. Again, please your attention on the upper right of the screen. We will talk about the terminologies which are very essential in our topic today. First is raw data. So raw data refers to the collection of data which have not yet been classified or organized numerically for statistical purposes. So these raw data, you may think of them as data which are kind of messy in a way, meaning they're not yet organized. Okay, and that's why the second step in statistics is organization, because after you collect those raw data, raw as in fresh, they're still fresh from the collection, so they're not yet they're disorganized. So what we need to do is to organize them. So we call them raw data. An array is an arrangement of numerical data in either descending or ascending order of magnitude. Okay, so when we arrange the data in an ascending order, we call that an array. Okay, so we call that an array. Next is the range. The range is a difference between the highest and the lowest values in an array. So if we're going to have this this arrangement of numerical data from least to highest, when you will get the difference, meaning you will deduct, you will minus, subtract the highest, okay, by the lowest. That's what you call a range. Actually, a range is one of those measures of variance or variability or dispersion. Next is the class frequency. The class frequency is indicated the number of observations within a class. So what is a class? Okay, a class or a class interval or simply an interval. Okay, the frequency, how many observations or data are within that class interval. So what is this class interval? We will talk about it um, here. Okay, so the title of our video today is organizing and summarizing quantitative data. So or quantitative data. Okay, the thing is they're in numbers, they are in quantity. Okay, and specifically we will be creating or we will learn how to create a frequency distribution for quantitative data. Okay, so how do we construct a frequency distribution for a quantitative data? First, we need to determine the number of non-overlapping class intervals, seldom called classes or intervals, k. Okay, so we need to determine this k or class intervals. We use between 5 to 20 classes. Okay, only 5 to 20. Use enough classes to show the variation in the data, but not so many that some contain only a few times. So again, the typical is 5 to 20. So fewer than 5 usually leads to inaccurate calculations, and more than 20 will be cumbersome to do. Um, Usually it is stated in the problem how many classes you will use. So in this particular problem, we will let our k, let's type it here, our class our class interval, we'll call that k is equal to 6. Okay, so our k here will be equal to 6. Okay, let's move on with that's our first step. So we have took our k as 6. Next step will be um, determine the width of each class, also called the interval size. So what's the length or the width of each class? How do we do this? So we will write first the range. We will get the range. We'll get the highest value minus the lowest value. So with that in mind, we need to get the highest value in this given data set. So what is the highest value there? So we will use, um, let's write maximum value or highest value. Let's write maximum. Okay. How do we get the maximum value? We'll just use some function so that we won't be searching in the whole of this data set. What is the maximum value? So what we'll use is equals max, open parenthesis. What's the max value of this data set? Close parenthesis and enter. The maximum value is said to be 33, which is here. And for the minimum value or the lowest value, we'll use the function equals min, open parenthesis. We're going to highlight all the data sets, close parenthesis, and hit enter. So the lowest value is 12. So I think that's that. So how do we get the range? The range is highest value minus lowest value. So what we can write is highest value minus lowest value, enter. So our range is 21. Okay, that's our range. Okay, now pretty much we have the range now. What are we going to do? The class width I is equal to the range all over the number of classes. So let's write here the class width, which is denoted by I. How about let's make the letters center so that we won't get confused. So the class width is equal to the range. We'll click the range here and then divide it by the number of classes, which is 6. So what our class width is 3.5, and we don't do class widths which are uh which are decimals. So we usually round this off. So how do you round off? Using Excel to make it legal. So click on that cell that you want. We will decrease the decimal so that it will become 4. So therefore our class width is 4. Okay, that's a legal way. Okay, Excel did that. Okay, so let's move on. Number 3, third step. What we're going to do is to determine the class limits. Okay, determine the class limits. By the way, I forgot, we need to write here. Why don't we write here the formula for our range? Okay, so that we won't forget. Maybe we'll use it in the future. So range is equal to the highest value. Let's denote that as HS, the highest value, minus the lowest value. And your class width I, your class width, let's just call it I, is equal to your range all over your number of classes, which is K. Okay, so just take note of that. So next is determine the class limits. Okay, so how do we determine the class limits? These are, we have two types, the lower class limit and the upper class limit. So identify the smallest possible data value assigned to that class, and the upper class limit identifies the largest possible data. So we can see that in our minimum, our lowest value is 12. So we're going to make use actually a table here. Let's put it here. So um, what we're going to do is we're going to write here class intervals. Okay, and then let's put here the lower class limit, or maybe we'll just put lower limit, and then we have the upper limit. So what we're going to do, since we know our class width is 4 and the number of classes must be 6, so we'll start with the lowest possible, the minimum value. So we'll start with 12, and then after that we're going to add 4 with that. So 12 plus 4 is 16, then 16 plus 4 is 20, 20 plus 4 is 24, 24 plus 4 is 28, and then we have 32nd. And then we end there since there are 6 already, and we say that it's only until 6 because we only need 6 class intervals here. And then for the upper limit, um, what we need to do is get the next lower limit and then just subtract it by 1. So we have 16 minus 1 is 15. And then with this, we can actually, from the first upper limit that we have, we will just add the class width. Okay, so with that, we have 15 plus 4 is 19. 19 plus 4 is 23. Sorry, 23. 23 plus 4 is going to give us 27. 27 plus 4 is going to give us 31. And 31 plus 4 is going to give us 35. Okay, so this is our lower limit and this is our upper limit. Maybe we can, what? well, margin center to make it better, to make it look better. Okay, so we have the class limits or the class intervals or the classes. We have six intervals. We have the lower limit here and the upper limit. Um, maybe you may create this in your own way. Yeah, you can do that. Maybe I can do it like something like this, and then okay, let's put it like that. Okay, and then lastly, okay, and then we'll align it going to the left part. Okay, and then it looks like a class interval. Actually, this is a limit. So meaning our first interval, our first class is 12 to 15, then 16 to 19, then 20 to 23, then 24 to 27, then 28 to 31, and then so on, 32nd to 35th. So those are our, all of these are what we call the lower class limits, and what we call here on the right side is the upper class limits. So we have constructed them. Next step is going to be count the number of data values belonging to each class. So this is where we will put our frequencies. Frequencies. All right, let's try the frequency. Okay, so now we'll be counting the frequencies, how many data are there between 12 to 15. So to do this, well, technically we will be tallying how many values are there from 12 to 15 in this data set. So, but hey, we'll use technology to count that. So what function will we use? We will use the function which is equals count ifs. So we know the count if from before, but since there are some some even more conditions, so we'll use count ifs. So just a plural count if. So first we're going to highlight our range, and then we will say what we want to happen in that range. We want the values greater than or equal to 12. Okay, so greater than or equal to 12. So make use of some quotations there, comma. We're going to use again or highlight again the same selection, because we want that selection to have, it should be less than or equal to 15. So it should be less than less than sorry less than or equal to 15. So, and then close parenthesis. What this is saying is that I'm going to count Excel is going to count this selection here, which is all greater than or equal to 12, and with the same selection, which is less than or equal to 15. If I'm going to click enter, it will give me 8. Meaning, in this type of data set, there are 8 who are between, who has a score or has an eldest child of parents in a given class of ages 12 to 15. Okay, let's do this with the same with the uh, with the same data, only with different intervals. So we're going to use again count ifs. Anyways, we can actually just copy and paste. Don't forget, what we will do is just lock the selections. We'll lock the columns, lock the rows. Likewise, lock the columns, lock the rows, lock the columns, lock the rows, and then we can use this now properly. Um, you can put your cursor to be all black and then drag it down. Now they're all 8 because we haven't changed the given class. So we need to we change that manually. So instead of 12, this becomes 16. Instead of 15, this becomes 19. So the answer is okay, still 8. Here for 20 to 23, so this becomes 20, this becomes 23. Okay. So okay, so meaning there's nothing wrong with our data, with our function. 24 to 27. So let's go 24, go into 27. Okay. There are 3. How many are from 28 to 31? So there are 3 also. And how many are there of the age 32 to 35? So there's only 1. Let's check if this is true. Sum. It should be 1, 2, 3, 4, 5, 6, 6 times 5. It should be 30. Okay, so let's sum them up. Close parenthesis 30. And yeah, what we're doing is correct. Okay, what we're doing, everyone is correct. Okay, so there are indeed 30. So that's a frequency distribution for the eldest child of parents in a given class using class intervals. So in your own class, you may want to trans or make this in the APA format. So you just need to copy and paste, okay, and transfer it to the file or wherever you want. Okay, let's proceed here to our next part of the slides. So actually, there are other components of a frequency distribution. There's a lot more, but I'm just going to choose and minimize, okay, and restrict myself with this. The class boundaries, the class marks or class midpoints, and then the percentages. The percentages are, we are aware with the percentages. So we can actually do the percentage here. Let's do that first because it's easier. Percentages. How can we get the percentage? Equals, we have did this in the previous video. 8 divided by 30. And we want this 30 to be not moving. So we'll put the dollar sign there for the rows and dollar sign there for the columns to be locked. So we'll put percent. So what we can see is this, and notice the decimal points are quite nasty to look at. So we will be um, deducting those number of percents. Let's make it how many? Two decimal places as a standard. So and then let's drag this. Put your cursor in such a way that it will be all black, and then drag this down all the way down. Okay, it will give 100. It will give 100 for the 30%. Okay, so that's the percentages. Let's proceed because I did that first because we're familiar with that already. So let's start with the class boundaries. Some may call this the real class limits or the true class limits. So how do we do this? These are specific points that serve to separate adjoining classes along a measurement scale for continuous variables. So as you can see in this limits, just look at the first two class intervals. So we can see 12 to 15, and then 16 to 19, and then 20 to 23. Anyways, let's focus here on the first two. What about if your value is 15.2 or 15.5? So there's nothing here with the 15.5 or 15.2 values. So the class boundaries answer that. So meaning they extend the class intervals in such a way that there's no gap between them. As you can see, 15 to 16, there's a gap of 1. 19 to 20, there's a gap of 1. So meaning if your values are continuous, that will be a problem. Good thing for us, our values are discrete. So meaning there's no decimal form. So if it's continuous, so that will be a problem. So the class boundaries, also called as the true class limits, does the job. So these are the numbers used to separate classes, but without gaps created by class limits. So class limits have gaps, like I said. So the number to be added or subtracted is half the difference between the upper class of one class, the upper limit of one class, and the lower limit of the preceding class. Okay, half the difference between the upper class and the lower class. So half the difference. So 15 minus 60, or rather 16 minus 15 is 1 divided by 2. So that's zero point 0.5 or 1 half. So we need to add that to get the class boundaries. Let's go back. Okay, so what I need to do is I need to transfer this first. I will move it here. Sorry. Oh, no, not meant like that. Cut and paste it here because we will be putting the class boundaries in this part. Let's merge that thing. Uh, we'll call this the class boundaries. Anyways, one more thing, you may follow a different format, but I will follow is this. So let's call this the true class limit. Let's just call it true limit, and then uh, or maybe we can just call this lower limit, and then yeah, why not upper limit? Just know that they are class boundaries instead of class intervals. So what we're going to do is we got the value, which is 16 minus 15 is 1. 1 divided by 2 is zero point 0.5 or 1 half. So meaning we're going for all the lower limits here in the class intervals, we're going to deduct by zero point 0.5. And for all the upper limits here in the class intervals, we're going to add zero point 0.5. So 12, 12 becomes 11.5, or maybe we can use some functions to make things to make our lives easier, equal sign, click it here, minus 0.5, and then voila, click this one and then highlight it going down. So those are the lower limits, okay? And then for the upper limits, um, yeah, let's put it like this. So these are the values. So what we're going to do is equals all these values here plus 0.5. Oh, oh no, they are read as negative numbers. Anyways, let's just have this and then have minus 0.5. Technically it should be plus, but here in my Excel file by some syntax or by some technicality it is read as negative, so it should not be negative. Actually, this is a line. I meant this is a line. And then there. So we have now the class intervals and class boundaries. Okay, so the class boundaries fills the gap. Okay, it fills the gap. Okay, so that's for the class boundaries. Let's move on. We will have then class marks or class midpoints. Um, this is the value halfway between the lower limit and the upper class limits. This is actually the midpoint of the classes, the middlemost part. They can be formed by adding by adding rather the lower limit and the upper limit of a certain class and then divided by 2. So how do we get the class class mark or the class midpoint? It's denoted by x, by the way. So we'll have the upper limit or the lower limit, if you want, the lower limit plus the upper limit, and then we divide it by 2. So for instance, here we have, I think I need to move this again. Okay, so we'll put here class marks. Okay, so look at this class intervals. What we'll do is we have, um, anyways, let's there. So it looks like it looks better. So what we're going to do is we're going to add this 12 plus 15 divided by 2. Okay, 12 plus 15 divided by 2. So what we're going to do is going to be like this. So equals this. It should be plus, right? It should be plus, but this is read as negative, so I'm just going to put minus. Okay, it's still going to be the same. So we know that we need to add them. So let's put them in the parentheses by the PEMDAS rule and then divided by 2. And then we have 13.5 as our class mark for this first column, or for the first row rather. And then we'll just drag this, and then voila, what we have is the class marks for all the class intervals. Notice that the class marks also follow the class width. So we have 13.5 plus 4, 17.5 plus 4, 21.5 plus 4, 25.5. So it still follows the class intervals. Let's proceed. We have then the percentages. We have solved that already. So dividing the frequency, my bad, by the total frequency and then multiply by 100%. So the formula is frequency over total times 100%. So we have done that. Okay, we have done that in here. So these are the percentages. Okay. Oh, wow. So actually, this is it. Okay. So this is the end of our video and the frequency distribution for quantitative data. So this is actually our frequency distribution over here. I just need some fixing. It depends on your writing style. So our writing style is the APE format. So we just need to convert this into the APE format. Okay. So that's it for the frequency distribution. Next up, we're going to deal with the graphical presentations of them. So this is it for this video. Thank you very much for watching, and I hope that you would like and subscribe, and see you soon. Okay, bye.